Hello, everyone. Welcome to IPND's webcast for today. My name's Kelly. I'm one of the Udacity coaches. And with me is Luke, and he'll be walking you guys through a really sweet mini project.
Okay, so good to be with you, Kelly. Today we're going to go over essentially a quick and dirty way of making a Connect 4 game right on your computer, using basically everything that you already know. I think when I made this the first time around, and I'll be making it in front of you again, I used a single maybe try except block that you might not be familiar with, and then maybe a Python library too, just to shorten things up that I didn't really need to use, that I used just for convenience sake. But let's dive right into this. So it'll look a lot like it normally would whenever I would do a problem-solving session live, having not seen the problem. Only this time I will already have solved it, because I don't think I could do it in an hour otherwise. So for the sake of that, I'm going to screen share.
Great. And if you're following along as we go, you'll just need a basic text editor that you have access to, as well as some console you can test things in.
Okay, so if you can see my screen, yes. Let's make it a little bit bigger. Making the wrong one bigger. Well, I'll say that's good. Okay, so we're going to make a Connect 4 game. So the first thing I'm going to do is I'm just going to save it somewhere. So I'll just save it right on the desktop. Actually, yeah, I'll save it with the other one. So that's the one I already made. So here we're going to call it Connect 4 Live. .py. So moving on from that, the first thing we're going to do is just outline what we're all going to have to do for a Connect 4 game. So things to do. So first, we're going to have to make and display a board. Obviously, if you know, for any computer game, you have to actually convey some information to the user who's playing the video game. This particular one might be a little bit more text-based because it's easier to work with in Python, but it won't really be. Ideally, you'd use a GUI, which is a graphical user interface, or something like that. But I just don't think we can do that in the time we have allotted. So we're going to do something that's in ASCII, so it's going to be entirely with text, but it's something that would be very easily converted to using a GUI if you had the extra time, without wasting your previous effort. Really, you'd just be wasting like a couple functions to display things. Your actual internal logic would all be the same. So first we have to make and display a board. Then we're going to have to be able to choose a location and then go there. So like pick a move and drop the little bit into the move.
And for any viewers that haven't ever played Connect 4, you might want to research what the board looks like. But they're like little plastic yellow boards that you drop red and blue tiles down.
So after that, I shouldn't say after that, we're just making a giant list of things we have to do. So we're going to have to actually alter the board based on what we choose. And then I suppose we're going to have to switch between players. I mean, if you have enough time, you could also make an AI for this. So an AI that could, it wouldn't be too hard to make one that simply like kept you from winning a very quick stroke, or if it could win itself, chose that option. But it wouldn't. Ideally, you choose an AI that could look several turns ahead, and sort of based on whatever ideal thing that you could do, it would do the opposite, since we're dealing with a zero-sum game. So it's not the opposite. It would maximize its reward while minimizing, while basically knowing that you are also going to do that. But moving on, we're also going to have a function of some sort, or just in general have our program see if the game is over. And that actually involves a subset of see who won, or if it's a tie. So ideally, again, the AI, probably not enough time for us to do that. But first of all, let's just see if we can make a board. So I'm going to have a pretty simple function here. I'm going to call it create board. And I'm going to take two things here as arguments, x and y. That's just going to be how wide it is in x and how tall it is in y. So I think Connect 4 games might be like 7x6 or something like that.
I think 7 spaces wide.
Yeah.
Yeah.
But I mean, you could theoretically just make one of any size. Obviously, it has to be at least 4x4, or it's not possible. But that would seem like a really weird and sad game if it was 4x4. So, yeah. But we'll create a board. To do that, first, let's decide what data structure we're going to use. And I'm just going to make it a list of lists. So from here, I'm going to make a board, and then I'm going to make a bunch of rows in that board. So that's what this for loop is for, just making a bunch of rows. For each row, I'm going to make that a list as well. And then for each row, I'm going to make a column. And this one, it's x wide. So now we have to decide what our actual things are going to be there. We're going to have to append something to our new row. I'm just going to append an empty list just because it's easy enough to check and it's prettier if you look at it. So this is going to append a list to every single time that we go through here. But we also want our rows to reset. So that's actually why we're doing this here. And I probably didn't do a good enough explanation of that because I'm going too quickly. So as you go down and create the board, which is your overall list, you're going to have to make a row for each thing. And we want to do that before we go into this loop because we want this row to capture every single item in the columns. Once those are all grouped together, we can add them to the board. But then every time it's going to loop through here, it's going to go back to here. It's going to reset this new row to be empty because it was added to the board here. Now it's empty, and then it gets filled up again here, and the new one's added to the board. So we're going to get a lot of stuff out. So I suppose let's just test this out to see if it works. So I'm going to create a board. And we said 7.6, so let's see what that is. Let's just print it out. Okay, so that didn't give me actually much information. So I'm going to actually do something up here. Python has this really, really useful module called pprint, which is just short for pretty print. And pretty printing is it's built into the Python library. And this is basically how you do it. And for any data structure, like a list of lists or lists of dictionaries or any JSON that you might come across, it basically just prints it out in the way that you would, in a pretty sensible way that a human might want to read it. So for instance, if I was to print out board, what I get is now an actual, really here we have a list of lists. So we're 3 deep because I made each item a list itself. If I continue moving on, it looks like that worked. So next up, I want to be able to actually put something into the board. So to do that, I'm going to, really we can't choose squares that we're putting in, we're choosing the row because it drops all the way down and you don't have a choice about how far it goes down. So I'm going to say it's choosing a row instead of choosing a square. And to do that, I have to know whose turn it is. And the board itself, I'm going to have to be able to update. And then I have to decide which spot I'm going to do. So I'll just stick with X because that's what we've been using up there. So to do that, so first of all, let's make sure that we can move there. So if so I'm going to designate that the top row is actually the last one here. So just the way that's going to work with X and Y. So if I was to put, if you were to, actually, I have an idea for this. For explanation of this, let's show what happens if you just put in X, Y to show where you are in the in each thing. Oh, okay, so that's not what. Oh, I didn't mean X, Y. I meant IJ. Sorry. And really, it's JI. So notice that we're not in our more familiar environment, and Y actually comes first. So we move out with the X's, and then we move down with the Y's, both starting from 0, 0. So this is the origin, and instead of moving up in this direction, we actually move, instead of moving upright, we move down right as the numbers get bigger. So I'll just undo that quick. But now back to choosing the rows. First, we want to check to see if we can move there. So this is basically saying if there is something, so it's not an empty list, because remember, we're setting everything as an empty list. Python has this characteristic called truthiness, where anything that is a, when you test to see if something's true or false, like this if statement, you don't actually have to use the word true or false or set things equal to each other for all cases, because a bunch of different things are viewed as true and a bunch of different things are viewed as false in Python. So basically any empty data structure, like an empty list or an empty tuple or empty dictionary, or it doesn't have to be mutable either. It could be an empty string, so just literally a string with nothing in it, or 0. They're all viewed as false in Python. On the other hand, anything other than that is viewed as true. So if you ever say like if 6, it's always going to be true. But moving on, we don't want this to actually do anything in the case of someone trying to choose something that you can't choose. We don't want that. So returning false there is sort of a warning of, hey, look, this didn't work. Ideally, maybe we throw an exception, but so the next thing I want to do is find out which spot I want to actually fill in. Because remember, you drop it. So if you're dropping the little plastic piece, you want it to go all the way down. You don't want to get stuck in the middle. So I'm going to start off at the top. So we're just going to call that 0. Current Y. And then while the board at current Y of X, while there's something, basically, if there's something there, we want to stop. If there isn't something there, we want to keep dropping. So this just adds 1 to current Y, since that's what I'm doing. So the next thing I want to do, actually here, I don't really want this to alter the board. Ideally, I would just return a board here, just in case I want to do some AI stuff later. And I want some stuff there. So here is a really useful, another useful standard Python library module. That module is copy. So what it does is if you have a data structure, if you have a bunch of mutable elements in it, so elements that can be changed, like lists or dictionaries, if you use that one of those elements as an argument to one of your functions, you can change it so that even if you didn't want to change it, it's going to be different, even because you passed it in. You don't even have to return it, it's just changed. If you don't want to do that, one way to get around that is to make a deep copy. So to do that, you could just copy.deep copy, and then I'm making that a board, just because I don't want to change the board when I do this. But now this new board, I'm going to say at the current Y that we've gotten to, and at the X, I'm going to append my current turn. So basically, I've just added something to the new board, and I just said new twice. let's go back. New board. So let's test that out.
So
Yep. Can you hear me?
each choice that is made, there's going to be that many copies of the board game?
Okay, sorry, you cut out for a second on my side. You were saying if there's going to be, for each choice that's made, if there's going to be that many copies.
Exactly.
So basically, because I create this inside the function, it's going to be destroyed when it's returned. So long as, so ideally, this isn't actually making a bunch of copies unless you store this somewhere. Because any variable that you create inside a function is destroyed when the function ends. So this is returned, but if nothing is done with it when it's returned, or if basically if it's not stored, it dies. So you won't actually be creating a ton of different copies of this. Well, you will be creating them, but they won't actually be stored. So you're not using up a whole bunch of memory.
Perfect.
So, okay. So as we move on, let's test this out. So we already made a board earlier. So let's, I suppose, first of all, let's just comment that out. But let's use this. So choose row. Let's put in, let's do X's and O's because that's easiest. Feed in the board, and let's feed in the first slot. And let's do that a few times. Let's just repeat this to make sure it's going the direction we think it is. And then let's, actually now we are going to want this. There. So let's see what happens. Okay, so that is going up like this, which is more or less what we were expecting. So basically this is the top and this is the bottom, the way this is just looking. But we're good with that for now. Let's actually make a better way to display this board just so that it looks correct. So let's do this again. So we don't really need anything for displaying the board other than the board. So let's just take that as an argument. We're going to do all this as text. So we'll start with an empty string. Okay, so now for every row on the board, and for every column in the row, actually we're probably going to want to make the row start. So let's say that the new row just starts with this character, just to be like put it in actual, give it some space to be put in, sort of like a tic-tac-toe board. Then I think then we're going to actually start to fill it in. So let's fill in some columns. I think this might depend on whether there's something in the column or not. So if we just add something to, so this column is the value inside of here, which right now will be either like on here, on the previous thing we just made, that's going to be either an O or a list with a single entry with an O in it, or an empty list. So let's just say that if it's an empty list, or if it's not an empty list, it's just if column, because then it can't be an empty list. We're going to add we're just going to add the column, and then since they're all lists, we know it's not an empty list, so there has to be something in it. So we're just going to add that in. And then we're going to add in another bar on the other side. Just to be safe, I'm going to say SDR here in case we make something other than X's and O's, like ones and zeros. But okay, so now we're going to deal with the possibility of it not being. So basically, now we're dealing with an empty list. So for an empty list, instead of what we just did, we're going to want to just add some space. So let's just do a space, and that's the wrong button. There we are. So this space is going to be. I'm basically assuming that the column 0 that actually I probably could take more things in here, and that would be that if what we're choosing from between, I'm imagining zeros and x's, which is why I have a space here, but I could technically take in the two possibilities and then fill in the length of the larger one, and then make sure that the space between these two vertical bars is always the same, just by like multiplying the length of the larger one. But I'm just going to stick with the assumption that it's all X's and O's, just because it's easier and we have a finite amount of time that we're kind of burning through. So now we're going to want to add some things. So we do want to actually put some space between the rows. So for this, there's something called a new line character, which looks like that. And then we also would like some spaces. So some dashes will be put in, and let's do that times the length of the board, but we really want the length of board 0, if I'm correct. We want the width of the board, the numbers of rows. Yeah, I believe this. Yeah, and the number of columns, I should say. We want the total number of columns, and that'll be like this. And then from there, we also want to put in the same. Oh, no. Now we want to basically put that into the display. So display is going to equal, let's see, we were inverted. So we're going down. Let's make it look like a normal tic-tac-toe. So let's go up. So to do that, we're going to actually put this before whatever we had, just to make it go up. Let's just return this to see what it gets us. So now we're going to, it's returning a string, so I'm going to have to print it out. Let's see what happens here. Okay, that is a start, but definitely has some problems.
So it looks like you might need another new line character.
Yeah, definitely looks like we need a new line character.
Added.
Let's see where. So I think that's just the same there. I don't really know why I did that. So okay, so we're on the right track. That mostly looks good. There's no top bar here, and can't see the bottom of my screen very well, but it kind of looks like there's, I feel like we might be able to put in that top bar. So doesn't really matter. Actually, it might actually look better like this without the top bar, but because then that's like the open slots that you put them in. Let's just put this in. Actually, it does look like this is one short, so let's add that here. Actually, this looks more or less like we want, so I can kind of copy this. Not the new line, though. Okay, so that should put it on top.
Yeah, that looks good.
So, yep, that looks good. Yeah, definitely looks good. Okay. So as we keep moving forward, so now we know this works. And let's just do these. So now what we're going to want to do as we are rapidly going through here, let us see. So we've altered the board based on, well, we can alter the board. We haven't actually done anything to actually let someone choose. So we did choose a location to, well, no, still haven't chosen a location. We've found a way to insert things into the board, but we haven't actually done anything to get the user to go there. So the next thing let's do is to get some user input. So players just to figure out who's going. So let's say there's a certain number of possible places they could go. Actually, first of all, let's define a legal move. So here I'm going to use something called the try except block just to make it easier, because I'm not really, for is legal move, I'm not taking in anything other than what the user gives me. And actually, it might be easier to do just know that I'm going to have something that lets me know if there isn't a legal move, and I'll come back to that. I can decide how that's going to have to get in there in a little bit. So I want to go through every row. So every column, I should say. I'm going through every column, and I called that a row for I don't know what reason. Probably because this is called possible rows. Let's fix that. So if it's a legal move, which we haven't really put in yet, but so if it's a legal move, then we're gonna put in. Otherwise, we're just gonna keep going, and that designates our legal moves. So now let's make a prompt to tell the user. This, by the way, might seem a lot like what you're doing in some of your stage 2 projects, because they're really related. So now we're just gonna see. I'm going to use something called string formatting, which means that I'm going to be able to format the string, and it basically is just going to take a list of inputs. So in the string, I can basically put things like brackets, and if I number them, I could either number or name them, and they will say I have A here, or some there. So this will print out player, and then this will disappear and be replaced by player. So I'll keep doing that. So ideally, I'd also choose not sure if I spelled that right, but and now I want both the player and the possible columns. Hopefully that works.
So with having these possible columns, that's making it so if one of the columns gets filled up, it's not going to be one of the options that they can select.
Yep,
right?
That is the exact idea.
Perfect.
So then we're going to actually get what their choice is, and we'll call it move because that's what we've been doing. Let's just start it off as by making it none, because that's an easy default value for saying that it hasn't really done anything yet. So while not move, so basically while they haven't chosen a valid thing, we're just going to prompt them over and over and over and over and over again. So we're trying to get something that's an integer here. And the easiest way to deal with users giving you something that's not the type you want is to have a try except block, which is what we'll do here. So here, a try except block, basically think of anytime you get an error in Python that crashes the program, a try and except block can make the program just keep going and just deal with it, basically. So like if you have an error of literally any kind that's not like an infinite loop, and any kind that would normally like crash a program and give you an error message and a traceback, this will allow you to catch that error, and then generally the idea is that you kind of skip that part of the whatever's trying to be done, so as to not crash the program. So for here, now that we have our prompt all there, I'm just going to get a raw input, and this time I really I want the prompt, but I really want that raw input to be an integer. So if it's not an integer, we're going to just keep on going through the loop until they give us an integer, which is what this except is for, if I could spell. We're just going to keep move as none in that case. I could have just written pass or something. The idea is that they're going to have to keep doing something until they give me an integer. And I really don't want while not move. I really want while move is not in possible columns. Okay, so from there, I need to actually define this is legal move because that function is dependent on it. So I'm going to use that same try except block, but just to say if this time I'm not trying to see if the user is giving me some strange input that I don't want as far as an integer or a column that's wrong. This time it's just in case there's an out of bounds exception. Really, I shouldn't need this try except block because it should have gotten caught in player input, but why not catch it twice? So this time we're just checking to see that it's here and it's out of bounds. Then we're going to turn true. So basically, if that spot that they're trying to go at the top level is empty, then we know that it can at least fit there. So then we're returning true. Otherwise, we're returning false. And really, if there's an error, then we're going to return false because they did something we didn't want them to do. So I should really test this now. So I'm going to have to move away from Sublime to test it because I'm suddenly dealing with user input. So let's do that. So let's stop for a second. Stop sharing.
Right. And if any of you had this type of issue working through your stage 2 project, you'll know that Sublime's built-in build won't allow you to do any like user interaction, like raw input. So you have to use terminal or something.
Yep.
Or git bash if you're on Windows.
So now let's just watch the test on. Let's watch the test on the terminal. So. Okay, so I'm already in the right location. So this time, Python connect for live. Let's see what. Oh wait, actually, before I do that, I want to save this. I want to actually have to call the thing at some point. So let's. We have our board already created here. You can't see this because I'm doing it really quickly here, but I'm basically just editing it so it actually gets the player input, so we can try it. Okay, so, oh, and I also never actually, I feel like I needed to return move there too. Sorry, I'm finding multiple things that I didn't do here, but, okay, let's try it out. So it wants me to choose from 0, 1, 2, 3, 4, 5, or 6. So let's say A. Okay, good. Didn't let me do what I wanted. So let's say 7. Still didn't accept my incorrect answer. Now let's say 4. Okay, so it actually went in 4 too. So 0, 1, 2, 3, 4. So we're good. It looks like it's working.
Perfect.
Yeah. Sweet. So that is, I feel like I didn't actually even, Did I choose the row with that? How did it update? Oh, I ran my old, okay, this is a problem. Okay, so I had a problem just now. And that problem was that I wasn't running the current version because it did far more than it should have.
It just kept going.
Yes. Okay, so now clear X, please select which column to enter. Please choose from these possibilities. And it gave me no possibilities. That's a problem.
All right. Perfect.
And it keeps on wanting to do that. So that means there's an error. So back to finding the error.
So that's an error with the possible rows that you created in the get player input function?
Okay, so let's screen share again. Okay. Back to the drawing board for what's going wrong here. So
one thing that I'm noticing is that for your legal move, I believe you want X rather than move for your parameter because you're referring to X. Or, you know, make those the same. Yeah.
Yes.
So I think it just made all of your possible columns not legal.
Right. Okay, so let's try that again quickly, and it immediately works. So you can't see it on your screen because I'm just testing it on mine, but okay, it works. That's good. Yeah, I'm not going to move back to that just because it's still have so much more to do. Okay, so now we have user input, but we haven't actually been able to choose anything and fill up the board. So let's do that. Let's make a main play game. Don't need that. So let's play a game. Don't need anything here. This is going to give us everything we need. So first, let's make a board. And since our testing here is like that, we're going to just undo this so that we don't have that confusing everything. So let's make a board still 7 by 6. This time I want to make some players, so let's give it a possibility of 0 or an O or an X. They're easy to tell apart. And let's say that our current player is that. So now we really should have something like while the game isn't over, just to play continually. But right now we don't have a get over function, so we'll fill that in as we go.
Could we just try doing it without the is game over, but just making one singular move and switching players?
We could. The main problem is we have to have some way for this game to end. So what I was going to do quickly is just what was I calling it? Just game over. I think board is all it should take, and we're just really going to say if the board at let's call it -1, -1. If it at any point gets there, we're going to say true, just for testing purposes. Otherwise, we're just going to return false. So this is basically saying that if you ever get the top right, top right completely filled in, then the game's going to be over. Otherwise, we're not actually going to end the game until that point, just for our testing purposes. So while the game's not over, I want to display the board, and it takes in the board. Then I want to get a move. So let's say that I want to move, and I'm going to get that from the player input. And that takes in the board and and this time it's going to be current player. I'm also going to want to update the board, and I think I already had that function to do that. So choose row. Again, I think that's right. I had it in a different order. Choose row. So current turn, board, and move. So I called this X up there. I called it move here. Then let's just switch players. So basically after every move, let's make the players switch. And the opposite. Right, 0. Okay. And then if it's ever over, actually that would just be it. So let's just display the board after it's over. So that should allow me to do that. So play game.
And in your display board function, does that have a print statement in it, or do you need to print it right there in play game?
I was just going to have this be done for now. So like cool. Ideally we're going to have display who wins and everything, but right now is game over just doesn't do anything and we don't really figure out who wins. So I just want to test this out and see if it works. So let's go stop sharing and then let's put in another test. So this time, see how it works. Okay, so it displays the board. It wants me to select from something. I'll select from 0, see what happens. It crashes, that's what happens. Player is not defined. So
we're going to troubleshoot that.
Right. Players. So I'm just going to do that quickly and stay over here. Okay, let's try this again. Okay, that's good. Now what happens if I say 4? Okay, cool. I think if I want this to end, I have to just do this a lot. Okay, good. Now it ended. So at least we know it kind of works, but it doesn't print board at the end. There's definitely supposed to put print board at the end. Oh, I didn't print it out. That's why. You'd think display board would print the board out instead of returning the string to print out, but I guess I did it weird when I remade it. So, okay. So now we're really getting close to having a fully functional game here. But we probably have the hardest step left. And that hardest step is to actually see if somebody's won, which will be really useful not just for making the game functional with 2 people, but if you want to make an AI, you're going to have to do that same thing about checking to see if someone's won, because that's how you're going to sort of project into the future, like see what all the possibilities are of them going somewhere or of you going somewhere after them, and filling in which one's going to be best for them. So making this back up. So now let's get to the hard work of making is game over correct. So this is all nonsense, so we're just going to delete it. First thing is let's just see if the board is full. We're just going to start out with true, because as soon as we find something that's not full, we can put it to false, and then we don't have to deal with it. But from there, let's go through every item in the entire board. And let's find out where we currently are just by this, so we don't have to do it multiple times. So the first thing we want to check to see is if, for everything, let's just make sure that the board isn't full. So if not current, which is to say it's empty, then we know the board is not full. So is board full equals false.
And just for visual reference, this starting the check if we were looking at the board in the bottom left and checking that very first space. And then we're moving to the right. So staying in the bottom, but going to the right. Is that correct?
Right. So for Y is going to be the vertical one. So then we start and we go all the way to the right, and then we finish that row, which is actually a bunch of different possible columns in that row. So we do the first row first, every column in it, then we move up to the second one, and keep going until we get all the way to the top. So in that same manner, we're actually going to check here for every possibility of the game being over. And we're going to go through every cell to do that. And what we're going to want to do is we're going to want to go first, say we have some square. We're going to first check up, then right, then up right, and then down right. Because that way we can do that from every single possible item in the entire board. And if any 4 of them are the same but not empty, then we know the game is over. So let's go and do that.
So you're just gonna create a sweeper to like look for things from each point, just going right since we're traveling right through the board.
Right. Okay. So getting on to that. So first we want to make sure we don't go out of bounds. So let's say if y plus 3 is less than the length of the board and current. So current is always going to have to be something other than an empty. If it's empty, then we don't want to deal with it. So honestly, if it's empty, we can continue, which is just a way to go to continue the loop but not do anything below it. So yeah, if current is, wait, if not current, no, I don't want else there. I want if not current, board is full is false, and I want to continue. Okay, so now as we're farther down here, so we're just going to check if current is there and that we can check the spots 3 above it. So this will be up. Actually, I'll put that up here. So now we're going to go, the shortest way to do this is just a multiple equalities. So I'm just making sure they're all the same. So yx equals y plus 1 x, and so we're just going up. And you can just check to see if everything is equal to each other with this in Python, which is awesome because some languages would make you write out each possibility here, which is really just comparing every single thing to the first one, but it takes longer. But we don't have to do that. It does it for us. So okay, I think that should be enough. And then if that's true, if all of those are equal and current is something, then we just want to return that. And let's just, instead of returning the list, just return the item in the list, which is that. And now we do the exact same thing for every other direction. We don't have to check down, because if we go through every item in the board, it's automatically going to check down by checking up, basically, because you're starting at every possible point in the board. So what would be down, say, starting from the top is just up from 4 down from the top. So let's check to the right. And the easiest way to do that is just literally copy and paste this and then flip out the x or the y's. So this time if it's plus x plus 3 and the board is 0, and then instead of the y plus 1s, we have the x plus 1s. Make sure you don't have typos like that. And now we can do the same thing for upright, only this time it's going to be both. So I'm going to want this as well.
So this is up at a diagonal to the right.
Yep.
Cool.
So we're making sure that both can go up at the same time. And putting this in. And then finally, we want to check downright.
Just going back to your third conditional,
yes.
the 2 and 2 and 3 and 3. Yeah.
Yes, that is a very, very good point. And I did that wrong again. Okay, there we are. This one's going to have a slightly different range. So instead of y plus 3, if we're going down, it's going to be if y minus 3 is greater than or equal to 0. X should be the same. So now instead of all these plus ones, we can just subtract, put them for minuses. Okay, so that's basically everything we have to do there.
Another 1 and 3 and 2 and.
Why am I doing that?
That's the horror of copy and paste. Those little errors.
Oh yes, copy paste, copy the same problem, have it multiple times. Now that we've looped through the entire thing, if the board is full, let's return just pi. So here we're returning the string, which would be like x or 0. Here we're returning tie, and otherwise let's just return false, because everything else is going to be a true. So is game over is false if it's not over. Otherwise it's true, but it's true in a very specific way. It's either going to be true. It's going to be true with the winner or the word tie. So now with that said, we can go into the play game and alter it slightly to actually have a winner. So let's just say print. Actually, let's say winner equals is game over. I'm running the function a second time, and I probably don't really need to, but oh well. And then okay.
Great.
So now let's try our game again. Okay, so let's clear everything out. Do this whole thing again. 3, keep going.
It looks like X isn't trying very hard.
X isn't trying very hard at all. Okay, looks like 0, 1. That's good.
Perfect.
So I think we're a bit over time, but we have a functional game that you could play with 2 people. To be more entertained by your own, you'd probably want to give it an AI, but that's, as you see, we've already went over time. So that would probably take as long as everything we already did.
Great.
But I hope everyone who watched this in some way learned something, or at least enjoyed watching it.
And if you have any questions for Luke or any of us coaches with any parts of the code that maybe you haven't seen within the IPND course, please comment on the video once it's posted, and we're happy to help.
Yep.
Cool. Thanks, Luke. See you later.
Thanks. Have a good day, everyone.